It may appear to be a mirage in the desert for the first-time visitor. Miles from its nearest neighbor, it's a 52 square mile self-contained facility. Isolated and secured, this unique testing facility not only offers transportation research and testing services to American and foreign railroads and municipalities, it offers a wide range of non-transportation services as well. The Transportation Test Center, located near Pueblo, Colorado. The TTC is operated and maintained by the Association of American Railroads Research and Test Department. The facility is owned by the Federal Railroad Administration, and together they work to improve safety, performance, and cost effectiveness for the advancement of railroad technology. Their long-term agreement ensures the continuation of a viable world-class facility.
The Transportation Test Center has, I'm sure, the most unique, highly qualified, capable, and dedicated group of employees involved in research and test work that exist anywhere. They can handle any kind of a problem that is given them successfully, efficiently, and cost-effectively.
One very important jointly sponsored program with the Federal Railroad Administration is the Fast Heavy Axle Load Project at TTC. FAST, which is an acronym for the Facility for Accelerated Service Testing, is the only full-scale railroad testing program in North America dedicated to evaluating track structure and equipment under heavy axle loads. FAST is capable of moving 1 million gross tons of railroad traffic in one day over test track. This is accomplished under tightly controlled and monitored research and test conditions. Since its inception in 1976, the FAST program has provided the FRA, the railroad industry, and railroad suppliers with a means to evaluate the performance of track and rolling stock designs under the rigors of actual service in a highly compressed time period. Besides moving freight cars, the TTC moves passenger and transit cars as well. The New Jersey Transit Authority is one customer that is running its modified transit cars around a 15-mile loop of high-speed overhead catenary electrified track at the test center. The track is maintained to strict railroad standards, and the test center also operates 9 miles of electrified third rail track, furnishing a variety of transit track representing metropolitan transit and commuter systems. Today's testing involves measuring wheel temperatures during stop braking. This procedure enables the test engineer to identify ways of reducing wheel temperatures to improve running efficiency and safety. The test parameters include operating the vehicle at speeds in excess of 100 miles an hour and are monitored closely at the Operations Control Center. Today, the train will be field tested traveling at its maximum operating speed.
Yeah, OCC, we've got 85, approaching 95. And 100.
Yeah, I copy your 100 miles an hour New Jersey Transit. Security advises that the lights are flashing, the barricades are in place at 85 and 100 for high-speed testing.
Operating the rail cars for 25,000 miles provides the New Jersey Transit Authority with tons of valuable data. From the tests conducted here, they can investigate the effects of wheel tread and dynamic braking on wheel tread temperature. The test center's isolation, open terrain and climatic conditions make it ideal for land vehicle testing. With a total of 48 miles of test track, a variety of testing can be carried out throughout the day. On one track, welders are busy testing a welding procedure. And on another track, signals and safety devices are being tested. Inside this 55,000 square foot high bay building is the Rail Dynamics Laboratory. The systems and instrumentation measure stresses and strains on a variety of vehicles, from buses to trailers to locomotives. The vibration test unit subjects vehicles to lateral and vertical forces. The VTU can transmit vibrations with frequency ranges of 0.2 to 30 hertz. Testing with the VTU identifies potential lading damage inside rail cars and provides valuable information for mathematical models. A computer commands the 12 electro-hydraulic actuators under the vehicle. Data collected from revenue service tracks, road surfaces, or other sources are fed into the computer. Extraneous information is edited out, leaving only the stress-producing actions for VTU input. This concentrates thousands of miles of track experience into a few days. The Roll Dynamics unit simulates the motion of powered and unpowered vehicles. Powered vehicles can be tested for acceleration, adhesion, braking, stability, and energy consumption. Speeds up to 140 miles per hour and track gauges up to 66 inches are possible on the RDU. For fatigue testing, the SMU or simulator imparts lateral and vertical forces. The SMU runs efficiently for an extended time, which makes it particularly well suited for accelerated fatigue testing. In a highly compressed time span, our staff can evaluate the 30-year fatigue life of a rail car. The SMU also lends itself to testing other vehicles, equipment, and structures. This data can prove to be a valuable design tool, powerful sales statement, as well as a safety factor. The Rail Dynamics Lab uses unique equipment. Though designed primarily for railroad testing, it is adaptable to other applications. By talking to our marketing staff, you can determine how the RDL meets your testing needs. Often testing at the RDL is less expensive and far more efficient than field testing. Our engineers and customers often prefer the controlled environment of the RDL and its accelerated testing capabilities. Also located within the RDL is our package container laboratory. This laboratory helps design and test shipping containers of virtually any size to protect your product as it travels through the distribution environment. The TTC uses its transportation expertise to ensure that railroad customers receive their products damage-free. The Transportation Test Center's greatest asset is its people, with a wealth of experts skilled in the multiple disciplines required to conduct a broad range of transportation research and testing. A prime example of our ingenuity is the New Cars software program. New Cars is a unique rail vehicle dynamics model that predicts the response of any rail vehicle to any type of rail geometry. The TTC promotes a quality program, and we always put our customer first. With a permanent staff of around 200, we test track and vehicles for many clients around the world. We've traveled as far as China, India, and most recently to England and Brazil. The burgeoning Sao Paulo Metro came to the TTC to test 3 potential transit cars for use in their system. For months, the international team conducted a battery of tests on performance and reliability. Many times, our staff members traveled to Sao Paulo as part of the project. TTC and Brazilian engineers worked together to achieve needed improvement in both the performance and safety aspects of the transit cars.
The work that TTC has done in Brazil and also here has improved the safety conditions and safety parameters to them in Metro São Paulo.
When clients get involved in field testing, TTC's support staff is there to help. Here in our Center Services building, technicians retrofit the forward truck on a test vehicle to allow for additional instrumentation placed on the unit. Strain gauges and temperature probes are strategically placed to monitor and record the activity. In this test, the customer is hoping new modifications in the suspension system will result in a better ride and will lower harmonic resonance of the car. This is a first in a series of tests. If successful, the changes will allow the client to modify existing cars to meet the demands of his customers. The test center is the only place where new and untried designs of freight vehicles can be tested. Later that day, a tank car is set for an impact test. Rigged with a raised coupler, a locomotive rams the tank car at different speeds. TTC engineers are testing the car's resistance to damage that might occur. The client and the tank car's designers wait for the results to see if the shield meets design specifications. If the shield holds, the improved design will work safely on America's railroads within weeks. This tank car passed. No leaks. Research and tests like these ensure that railroads continue to be the safest way to transport large quantities of hazardous materials. However, in the event a spill occurs, chances are the hazmat team responding to the scene was trained at the Hazardous Materials Training School at the Transportation Test Center. It's Thursday evening, and a train accident has just happened. This time, it's a derailment. One of the tank cars is on fire, and another leaks a mysterious vapor. Within minutes, the Hazardous Materials Response Unit is at the scene. Everything is under control. This emergency is not real. This staged disaster concludes the hazmat training classes for this particular training session. No other training facility for hazardous materials uses a derailed train. No other training facility provides classes with the many real-life challenges. Keeping a close eye on the event are hazmat school instructors. Their job, to play the roles of a train crew, local fire officials, even spectators and TV camera crews. They will help and hinder the students in their quest to extinguish this emergency. Also included in this exercise, and unknown to the students, is a tank car explosion. Elements such as this teach the students to be alert to the uncertainties that accompany an accident of this nature. The rear tanker explodes. The team reacts and dispatches a fire crew to the scene. Later, another crew goes in and closes the leaking valves. The entire exercise takes less than 3 hours, a record for the school. The Transportation Test Center, located near Pueblo, Colorado, is known for its rail testing facilities. 20 years ago, we began as a high-speed ground testing center. We've come a long way since then. With its remote location, on-site emergency crews, and data collection systems, the TTC is ideal for your research and testing needs. We have unique equipment and a distinctive staff of experts. We can tailor our facilities to fit your specific needs. Whether it's vibration testing on a newly designed car, computer simulation, track component testing, car performance evaluating, or even commercial filming, the TTC can serve you. Back on the track, testing continues. Elsewhere at the test center, a new test is being developed for the transportation needs of a public concerned with cost, speed, reliability, safety, and the environment, and meeting those needs for the 21st century. Call the Transportation Test Center's Marketing Department for more information. The Transportation Test Center, dedicated to being a leader in the advancement of railroad technology.